Hello everyone and welcome to Connect.Tech. My name is Douglas Starnes. Thank you for joining me for the next half hour. A little bit about myself. So I'm from the Memphis, Tennessee area, and one of the things that I do in the Memphis, Tennessee area is I run user groups. So I help out with user groups ranging from .NET to Python to Xamarin to Power Platform. So there's definitely some data stuff in there. I also help organize conferences, so I'm on the organizing committees of TDevConf. We had our very first one about a week and a half ago, 2 weeks ago. We'll be putting some of the recordings of those sessions up online on our YouTube channel very soon, so watch out for that. And I am also helping to plan Scenic City Summit. That is normally in person in Chattanooga, but for the same reason that Connect.Tech is going virtual this year, Scenic City Summit will be virtual on November the 6th. So go to ScenicCitySummit.com and check that out. In addition, I am also a Microsoft Most Valuable Professional in developer technologies, and my day job is I am a tech author. So I create both video and written content. I've been published by Pluralsight, also just started doing work for a company called RealPython, and I have some content on Skillshare as well. So here's our problem. In the world of data science, we are literally drowning in data. I mean, anytime you interact with something digital, it's recorded. There are sensors all around us measuring air quality, the number of cars, and a stoplight. You go on Amazon, you make a purchase. It immediately compares that purchase to other people who made the same purchase and recommend your purchase to them and recommend their purchases to you. The phones that you carry around, they're collecting data about where we are, maybe our health or our sleep, or keeping track of how long we were in a meeting. So you could basically say that each one of us is a thing on the Internet of Things. And parsing this data is a real problem, and getting into how we can understand this data without actually looking at the numbers can be a problem. Now, the tool that we can use to extract, or as I like to say, let the data tell its story, is something called a visualization. Visualizations, as I said before, they tell the story of data using a visual or graphical presentation. And this makes it very easy to grasp that story very quickly. Now, we have many ways of doing this. So there's a language called R, and R is a language for data science, and it is fantastic for data science and fantastic for visualizations. But the problem is it's not really good at doing anything else. Now, there are other more general purpose languages out there like Python. Python is a fantastic general purpose language. It's very easy to learn. It's very easy to use. I like to say that you can become dangerous in a weekend and useful in a week. Also, we're talking about getting your visualizations on the web. Python is a great language for web apps. So you've got Django, you've got Flask, very popular web application frameworks. And Python is also a very popular data science language. So you have Matplotlib that is designed for creating visualizations with Python. Now, there's a problem, which is that it's possible to get Matplotlib visualizations on the web, but it's not really that easy. And also the process is designed for data scientists, not web developers. Now, to complicate things, web developers use lots of languages. You know, they may use C# or Node or PHP. They don't necessarily use Python. But one language that they all use is JavaScript. And that's where D3.js comes in. So D3.js, or commonly referred to as D3, it is a JavaScript library for web visualizations. And again, it's written in JavaScript. It's open source, and it is, here's the homepage, d3js.org, and as you're going to see here in just a minute, D3 is very, very capable. It's flexible enough to create just about anything, or really anything. So without any further ado, let's go ahead and take a look at some examples of what D3 is capable of. Now, this is the D3 gallery, and this is a bunch of examples. And if I just scroll through here, you'll be able to see that there are a wide range of visualizations from the very simple to the very complex. Let's take a look at one of them. So this is a histogram. A histogram is basically a representation of frequency counts. Now this particular histogram is telling the story of the unemployment rate in U.S. counties from the month of August 2016. And this data came from the Bureau of Labor Statistics. It's available online, so you can actually go download this data or any other data and play with it as you like. Now, along the x-axis down here is the actual unemployment rate for each particular county. And then on the y-axis is the number of counties that had that particular unemployment rate. Now, to be more specific, down here, you see we've got these bars, each of which represents what we call a bin. And a bin doesn't actually represent a specific unemployment rate, but it represents a range of unemployment rates. So, for example, this one might represent like 2 to 2.5, and this one's 2.5 to 3, and this one's 3 to 3.5, and then 3.5 to 4. Now, the height of the bar determines how many counties fit in that bin. So in other words, we can see here we've got almost 450 counties that have got an unemployment rate of what? That would probably be about 4.5 to 5%. And we can also see that some counties had unemployment rates as high as about 24%. Now, if you look below the histogram, you'll be able to see the code that was used to create it. And I want to call your attention to this particular line right here, which is the data. And it's an array, and each of these data points is the unemployment rate for a particular county. Notice how many of them there are. 3,219. If we were going to go through these by hand and categorize all of the data by hand into the different bins, it would take a lot longer to figure out how many counties had a 10% unemployment rate, which is going to be less than 50, by examining all 3,200 data points than it did just by looking at this histogram. Another popular visualization is the line chart. Now, with the line chart, each point in the visualization represents an individual value, not a range of values. In this case, what's being represented is the daily close price of Apple stock up here, and it looks like we're going over about 4 or 5 years. Now, each data point in the visualization, they're connected with lines, and that allows you to see trends. So, for example, if you look over here, we've got the date on the x-axis and the closing price on the y-axis. If you look over here around the beginning of 2012 up until just about the beginning of April, Apple was really doing pretty good, and then they started to fall off a little bit. And then over here you can see that stock didn't really do that much right here, and then it began to have a gradual increase, and then again did that. And this also is a great example to show how the same data can be represented in different ways. So, for example, a popular choice among investors to visualize financial data is a candlestick chart. So each of these candlesticks, as we call it, represents multiple pieces of information, rather. So, for example, if we take this one right here, you'll see that you'll see that these sticks here, those represent the low price throughout the day and the high price throughout the day. And then you also have the opening price, and you also have the opening price and the closing price in there. Also, there's something else that you can see from this. If the stick, the colored part, is actually green, and it means the stock closed higher than it did the day before, and if it's red, it means it closed lower than the day it did before. So, in other words, you're packing a lot of information into a very concise form that you can quickly interpret at a glance. Another popular choice for visualizations is the bar chart, and this is probably what many people think of when they think of a visualization. Now, a bar chart simply represents, again, individual points. But in this case, what's happening is the bar chart, the order, can be often manipulated in different ways. So what we have here is we have the frequency of letters in the English language. So E is the most commonly used letter, T is the next most commonly used letter, and so on, whereas X, Q, and Z are less commonly used. This particular bar chart is sorted in descending order, but I could easily sort this in ascending order, or I could sort it by the letters. The bar chart, depending on what perspective I wanted to see the story from. So bar charts give you more flexibility depending upon your data, and of course bar charts can be turned 90 degrees so that they're horizontal rather than vertical. Now here's one that you've no doubt seen quite a bit of, another usual suspect, the pie chart. Now the pie chart is different in that it shows parts of a whole. So what this is showing is population groups by age. So for example, between 10 and 14 here, there's about 20 million people, and this is in the United States from 2015. Now, one thing that you can see about this chart is you can see obviously that there are more 10 to 14-year-olds than there are 80 plus, and that would make sense. Also, they've used color. This is an excellent use of color here to distinguish the different wedges from one another. So that's the reason that the pie chart gets its name, is because each of these wedges is a slice of the pie, and the larger the wedge, the more of a slice of the pie you have. This is the scatter plot. Now, first of all, the scatter plot is a little bit different than, say, the bar chart or the line chart, in that while it plots individual points, each individual point is actually based upon two values. So, for example, this is basically talking about cars. And what we have down here along the x-axis is we have the miles per gallon, the fuel efficiency of a car. And along the y-axis, we have the horsepower for a particular car. So if we look at this guy right here, we can see that it's got, about 23 miles per gallon and about maybe 50 horsepower. And what you can see from this is that you've got a trend going here. The more fuel efficient a car is, the lower the horsepower, and the inverse is also true. The higher the horsepower, the less the fuel efficiency. So that's the overall story that this data set is trying to tell. However, sometimes there's more to a story. And this particular variant of the scatter plot, there's some extra code in there that will allow you to, I'm going to scroll down so that you can see this, so that you can drag and select a group of points. And if you look down here, this selection, it's actually showing there that this particular one has 107, and if I drill down in, you would be able to get more data about those points and say, I want to just look at the story in this particular set of points. Also notice that the ones inside of the selection are colored blue, whereas the ones outside of the selection are colored black. I could also move this around. So if I want to compare two parts of the data, I could do that. And if you'll notice, the selection, the number in the selection down below, is actually updating in real time as I move this around. This is another example of how you can use the same data set and represent it with multiple visualizations. So back with the histogram, we saw how you could represent the unemployment rate or visualize the unemployment rate by counties. This is the same data set here, but it's represented using a map. And one of the things that D3 excels at is making maps. It's really, really great with it. If you've ever tried to work in any kind of geospatial visualization at all, it can be really difficult, and D3 makes it easy. This particular one is called a choropleth. I have trouble saying that sometimes. But each particular county is filled with a shade of blue based on its unemployment rate. And as you can see up here from the legend, the darker shades are higher unemployment rates, whereas the lighter shades are lower unemployment rates. So you could go over here and you can say in Alaska, unemployment was a problem, and over here towards the western part of the country, unemployment was more of a problem. Now this also, you could say that this represents population centers, but at the same time, and then you can see that right here there were some pockets, geographically that were having problems with unemployment. Whereas over here in kind of the Midwest part of the country that it wasn't as bad. Also what you can do is you can hover over any one of these and it will tell you the name of the county and the actual unemployment rate for that county. Here's another cool map. Now this one I had to zoom out a little to fit it within the resolution for recording. But this is a global map actually. And this is what's called a Voronoi diagram. And I'm actually going to zoom back in here so that you can see it a little bit better. But a Voronoi diagram, basically what you have here is you have a whole bunch of polygons. And inside of each polygon is a point represented by a red dot. And basically the idea is that if you're inside of this polygon, that the red dot represents the point, or rather I should say that inside of this polygon, any point that you're at, you are closer to the point represented by the red dot than any other point inside of the visualization. Now these red dots represent airports in the world. So in other words, if you're inside of this polygon right here, or rather let's take this one here, and you want to get to the closest airport, that's going to be it. Now over here we're out, in the ocean or unpopulated land or an island or something. But notice that I can also interact with and drag this map, and I can see this looks like, I believe this is Europe over here. Here's the United States. So here's the West Coast. Here's Southern California. Lots and lots of airports. New England over here, but again in the Midwest states, some of the lower populated areas, you'll see there aren't as many. But one thing I want you to see is look at this, how smooth the animation is, and also things aren't getting distorted because D3 uses vector graphics. So it's very easy to zoom in and out and do things like that. Now there's one more, and I'm going to have to zoom out again a little bit, that I want you to see. Now this one is kind of for fun, but it shows you how far you can go with D3 and how capable it really is. Notice that we're starting off with a group of circles, and these circles are randomly being split into 4 smaller circles. Now this was generated by an image, and as the circles become smaller and smaller, you're going to be able to see the image revealed over time. And what you're going to see is that it is an image of an owl. So as you can probably see right here, looking right here, here are the eyes. You can see the general outline of the owl is going to be around here. Here are his feet down here. You're going to start to see the beak come in here, and also you'll be able to see some of the coloring in the feathers and such. So now you can really see his eyes really well. After about several minutes, you actually won't be able to even tell that you can see the circles getting smaller and smaller. But as you can see, this is pretty clearly a picture of an owl. And again, does this have any useful purpose? No, but it does show off the capability of D3 and how far you can take it. So I want to look at some examples of how to use D3 here really quickly. And I'm not going to be able to cover how to do anything as complex or as flashy in the gallery because there just isn't time. But I do have some examples that will show the basics. Now, first of all, I'm using an online IDE called Code Sandbox to demonstrate the examples today. And basically that's a stripped down version of Visual Studio Code that runs in the browser. But this way what you're going to be able to see is you're going to be able to see the examples and the code both, and this is live. You can actually make changes to the code and see the outcome in real time. And you can even, it's similar to GitHub in some ways, that you can actually fork these examples and create your own copies and play with them, and I'll provide links. So this first example shows how you manipulate the DOM in D3, and the document object model provides an API to work with that. And a D3 visualization is no exception. So except D3 goes about it a little bit differently. There's a primary object in D3 which is named creatively D3, and it's similar to the $ in jQuery. Everything eventually comes from the D3 object. Now there's a select method. As you can see in this code here, in the select method, we'll select an element with a particular with a particular CSS selector. If I look over here at the HTML, you'll see that I have 3 divs with IDs of red, green, and blue, and over here I'm selecting each of those. So once I've selected one of those, I can then do something with it like modify the style. So I'm modifying the color here to represent the ID of each div, and over here you can see the results. And like I said, this is live, so I could say purple, and I could save it, and now I am blue says purple. Now sometimes you do have to hit this refresh button over here for it to get it to render. Now in this example, we're actually going to create an Svg element. Now Svg is scalable vector graphics. It's basically a standard for creating vector graphics inside of the browser. And D3, like I said before, D3 is highly dependent upon scalable vector graphics, and that's what gives us that nice visual appearance. So what I'm doing over here is I actually have in the HTML is I have an Svg element with a height and width, and then this is going to be the container for all of the graphical elements. In the code, I'm going to create this by putting inside of the Svg container a circle, and I've got different attributes for that circle. So for example, I've got the x and y of the center, got the radius, and I'm going to fill it with red. And of course over here you can see that what we get is we get a red circle. And I can modify this, so I could make this a 260 and save it, and you're going to see the circle gets really, really big. And then I could make this a, I don't know, yellow. And there we go. Code Sandbox gives you a way to quickly experiment, and it's a great learning tool as well, and also for sharing and collaboration. Now, visualizations are pretty useless without data. So this example shows how to bring data into a D3, or how to work with data using D3. This is actually not a visualization, but at any rate, over here in this data folder I have a JSON file. And JSON is just one of the many types of data sources that D3 can work with. And what I've got is I've got a very simple file representing statistics about ticket sales for conferences. And if you go back over here to the index file, what you'll see is I'm using this JSON method to load that data. Since loading data can take a long time, it actually returns a promise. Then when the promise completes, it'll call this function here and pass the data set into it. This function will iterate over the data because the data is actually an array, a JSON array. And for each element in that array, what it will do is it will call the generate div function up here, which will take that data object, or rather take some text and create a text node based on it and return it. And then that text node will then be appended to the body of the document. And notice what we're passing in here is the conference name, name of each conference, and we get this result right here. That's how you load data into a D3 visualization. So now we've actually got the basics, the 3 basic skills that we need in order to begin to create an actual visualization. We know how to work with the DO, we know how to work with the DOM, we know how to create shapes and graphic elements, and we know how to get data. We know how to import data. So this visualization here is a very simple bar chart. It uses the exact same JSON file as we saw before, but it just does something a little different. So what's happening here, and there's some D3 magic that I'm probably going to kind of do some hand waving over for the sake of time, but we'll look at the obvious parts. So the data here is being used to create each of these bars. Now notice there's no for each here. D3 is actually this method right here is actually what it'll actually do is it'll look for any existing elements and apply the points in the data set to those first, and then it'll use the instructions down here to construct new elements for any remaining data points. However, since we have no existing data points, everything's being created from scratch. So we're really starting down here with this part. So it's going to create a rectangle for each data point, and then the x coordinate, so in other words the left hand side, and the height are going to be constant. So every bar is going to start in the same place and they're all going to be the same height. Then what's going to happen is for the Y position, which is going to be over here on the Y-axis, it's just going to space them based on the index of the data point. And then the width is actually going to be the number of tickets sold for each data point, which is taken out of the JSON. And then everything's filled with green. Now, notice that in some cases you can have just a value for an attribute, but in other cases you can also have a function. And that function will be passed the current data point and the index of that data point. And so that's how I can iterate through the data. I can also add text with SVG and D3. Got the same bar chart right here. However, down here's where I'm adding a text element for each one as well. And all I'm doing is simply telling that text element I'm passing it a function that will get a data point, and I'm merely using string interpolation here to get the difference of the, or not the difference, but rather get the conference name and then the number of tickets sold, and positioning to put that below each bar. Also notice that since I have font size now, since I'm as an attribute, since I'm using text. And here we come to the last example, which is the most complex. This one not only shows the number of tickets sold in a bar, but it also shows the number of tickets unsold. And then the text now includes the percentage of tickets sold, and since I moved the actual number out of the text, I've put it in the bar. Now, this presents some interesting problems. So first of all, calculating this percentage on the fly is actually no big deal. It really doesn't use anything from D3 at all. Just uses a little bit of math and something from the JavaScript standard library. The bars, the green bars in the text, are otherwise created the same way. Now, this red bar over here, this is the one that's a little bit interesting. So this is where the red bar is being created, and the x attribute, or the x coordinate for this, I want this to be on the right side of the green bar. So I'm just going to offset it by the number of tickets sold. Then as far as the width, what I'll do is I'll take the difference between the number of tickets sold and the number of available tickets and simply make that the width of the bar. Now, here is something, and I'm going to fill it with red. Now, here is something interesting, however. Notice that instead of looking for rect, I'm looking for rect with an ID of foo. And this can actually be anything. I think I used diffs in the original example. And if I take this out, notice it doesn't show the red bars, because so what it's saying is, I'm saying that this is a completely different set of elements, and I want them to be rendered in a completely different way. So if I put foo back in, it'll show up. And then as far as the text over here, that's simply again text with just using text elements, and I'm just positioning it relative to the rest of the elements in the visualization. So I know that was a whole lot in a short amount of time, but I will leave you with these resources. So the first 6 links here, those are the examples on Code Sandbox. Again, you can fork those yourself and play with them and see the results in real time. The last 3 links are actually some guides on D3 that I wrote for Pluralsight. These are freely available. They're not behind a subscription or anything, and you'll actually see that I use those examples inside of the articles. So, with that, I want to thank everybody for choosing to spend some time to watch my presentation this afternoon. Here's my contact information, so you can reach me by email, powered by AltNet on Twitter. I also stream on Twitch. I'm under Binary Chef. So once again, thanks to Pratik and Vince for having me again this year, and thanks to everybody for watching. Please feel free to reach out if you want to continue the discussion. Thanks a lot. Enjoy the rest of the conference.